Mainly what we're going to look at, though, is the slope. Remember that a negative slope means that your line would go downward as you look at it from left to right. Now, why would you even want the equation of the line? Well, the thought is, just to give you an idea, is if we have, let's say, a scatter plot that kind of looks like a line, if we can come up with the equation of the line, y equals something, I'm making this up, mx plus b. We don't know what it is right now. Suppose we wanted to make a prediction for some x value, I'm going to call it a, where there's no point anywhere in our graph at a. Well, if there's no point anywhere in our graph at a, what we could do is we could use the line as a good approximation. So we can take the a and plug it in wherever there's an x to figure out what the y would be to come out of this equation, and it would be a prediction that we could make. However, the only way we'd actually want to do this and use the line to make a prediction is if we have a good, strong linear correlation. If not, there's no point in using the line. So, if we have an R value that's going to tell us that we should have a strong linear correlation using an R and an alpha, if they tell us that there is a linear correlation, then we can use the line to make predictions. Okay, what if we don't have a good R that tells us we can't say that there's a linear correlation? Well, if you can't say that there's a linear correlation, then what we're going to do is instead, we're just going to take all the y values from your list, and what does that bar mean? That bar means we're going to take all the y values and just average them. So if there is no linear correlation, what we'll do is just average the y's. And it's just what we used to do way back when. You'll just add up all the y's and divide by however many y's you have. So let's go back to our example. From our example, we have an equation for our line that we just came up with, which was y equals the negative, we've got the negative 0.003x and the positive 1649. So what we want to do is use that line, if we can, to make a prediction about what's going to happen if we have a crash fatality rate of 300 metric tons. That's what they're specifically asking me here for. So what if we wanted to make a prediction about the crash fatality rate for 300 metric tons of these lemon imports? Well, if we have a good R value that would say that we've got a linear correlation, then we can just use that 300 here and plug it in wherever there's an X. Well, let's go back. What was the R that they gave us from our LinReg t-test? Well, if we go back a ways, we can see that the R value that we got was a negative 0.96. Okay, so if we have an R value of negative 0.96, that is pretty strong because it's very close to negative 1. So what that would mean is that we have a strong negative linear correlation. So because it's strong, because it's close to negative 1, we're going to go ahead and use the line. So we will take our X like we suggested, plug it in. We'll take that 300 and plug it in wherever there's an X. And we get out 15.59 for our Y. And that's our prediction that we're going to make using our line. Is that a for sure answer? No, it's just a prediction. And we were only okay using the line to make a prediction because of the R being so strong and so close to -1. Sometimes they will actually even give us an alpha to look at to determine if the correlation is good enough. So if you have a correlation of, let's say, 0.75, you may not be able to tell if you can use the line or not unless they give you an alpha to determine, like we did in 10.1, whether or not there is a linear correlation, either using a P or an alpha to create a rejection region. To determine if there is a linear correlation, then yay, use your line. If there's not, then you have to just average your Y values. Now, what if we use the same exact problem, but what if we had, instead of getting the -0.96 that we got for R, what if R had instead been -0.24? Well, if we had gotten an R value of -0.24, that'd be really close to 0. So you'd say that there is no correlation. And you'd say, well, then I definitely cannot use the line. So if there's no linear correlation, why would you use the line? So what do you use if there's no linear correlation, meaning you cannot use the line that you came up with? Well, then you go back and you look at your entire list of Y values. Well, let's keep on going. Our Y values were the second group, the fatality rates. So what we would do is, to make a prediction, instead of plugging in an X value, what we do is just take all the Y values we have and average them. Again, what does it mean to average something? It means to add them all up and divide by however many numbers you have. In this case, this would be adding up all 5 numbers and then dividing by, we've got 5 numbers, so we'd be dividing by 5. And let's see what we would come up with. We would come up with something actually pretty close. We'd end up with 15.44. That would be our prediction for any X value that they gave us, because we can't use a line. There's no X to plug in. We would just always use 15.44 as our default for whatever our prediction is, because we can't use a line.